So when you're comparing objects and comparing strings, because strings are objects, you got two options. You can use equal equals, which checks to see basically if the references are pointing at the same object. And then you've got dot equals, which compares the contents of the objects to see if they're storing the same stuff, and then compares them to see if an object's larger or smaller or equal to another one. So we'll look at all three of these. So in this example, I've got one referring to comp sci, and I've got two referring also to comp sci. So if I say if 1 equals 2, both 1 and 2 are referring to the same string, meaning they're storing the same location / memory address, meaning they're equal. So this one's going to print out equal equals. Okay, in the next example, I have one pointing at a string that's storing comp sci, and instead of pointing to at the same one, I'm pointing to at another string that's storing comp sci. So they both 1 and 2 are pointing at string objects that store the same letters, but 1 and 2 are pointing at different string objects. So whenever I look to see if reference 1 is storing the address of the same string as reference 2, that's going to be false. So this one's going to print out not equal equals, because the two objects, they have the same values, but they're distinctly different objects. And so 1 would have a different address / location than 2 would, because they're pointing at different strings. They have the same values, but they're different objects. So here's some string methods, and there's a lot of different ones you can look at here, but the ones that we're most concerned with are equals and compareTo. And so that's what we're going to look at in the next few examples. The trim, replace all, uppercase, lowercase, those are useful things, just we're not ready to discuss that yet. Okay, so the equals method. With strings, the equals method is going to go to the object the reference is pointing at and look at the letters that it stores. And it's going to compare those letters to whatever other letters it is that you provide as parameters to the equals method. So here I have string 1, which is pointing at the object big. Okay, and then I say string 1 dot equals it, meaning I want to go to the object that string 1 is referring to and check its letters to see if they match the string its letters. And so big and it are not the same, so it's not going to print out equal equals it. And then I'm going to check to see if string 1, the object it's referring to, has the same letters as big, which it does, so it's going to print out equal equals big. Okay, now I'm doing a similar thing to what I just did, except instead of using two distinct if statements, I'm using an if else. Now I check to see if string 1 equals it, big and it are not the same, so it's going to go down and print out not equal to it. With the two distinct if statements, it behaves differently than it does with the if else. Okay, so now I'm looking at using not equal. With not equals, I'm going to put the not operator in front of the dot equals call. So if it comes back true, not true is false. If it comes back false, not false is true. You get the idea. So I'm checking to see if it doesn't equal it, which it doesn't equal it, meaning my if statement will be true, and it's going to print out not equal to it. Okay, so here I'm doing the same thing again. I'm checking to see if 1 and 2 have the same letters. The 1 reference and the 2 reference, they're both pointing at the same object, the same string that stores big, meaning dot equals is going to come back true because they have the same letters because they're pointing at the same object. And in this example, I made two distinct strings again, storing the exact same letters, so my dot equals check is going to come back true as well. So whether they're pointing at the same string object or different string objects, as long as they have the same letters, we're good. The only time this comes into play where it's going to be a little weird is when you're using equal equals to compare the addresses / locations stored in the references. Okay, compareTo. compareTo gets a little sticky. It gets a little sticky because you're going to start dealing with ASCII values. And I don't know, it's been a while since we talked about ASCII values, but you probably need to go back and review your ASCII values, because capital A is 65, little a is 97, and then you got 0, which is 48. So what we're doing here is when we say 1.compareTo 2, we're basically looking for the first 2 letters in the 2 strings that differ, right? So the first 2 letters in the 2 strings that differ would be R and U. And in ASCII value, they're 3 characters apart. Right, so the ASCII values differ by 3. So if I say 1.compareTo 2, it's basically saying R minus U in terms of ASCII value, so it comes back -3 because the ASCII value of U is 3 bigger than the ASCII value of R. When I say 2.compareTo 1, then it's essentially saying 1 minus R in terms of, not 1 minus R, U minus R in terms of U's ASCII value minus R's ASCII value, which would come back 3. So what you're going to need to do with this one trust me, this is going to be weird for a while. You're going to need to go and mess around with the code, do some research, look up some ASCII values, and just understand with compareTo, when in terms of strings, it's going to start at the beginning, the 0 position of both strings, and look to find the first 2 characters that differ. It is then going to return the difference in ASCII value between those 2 characters. And it all depends on whether you compare 1 to 2 or 2 to 1 in terms of your objects, in terms of how it's going to come out, whether it's positive or negative. If it comes out negative, that lets you know that the first string was less than the second string in terms of its ASCII value. If it comes out positive, that means the first string in the compareTo was larger than the parameter that you passed in. So once again, we'll go look at this in some code, and this is just something that you're going to need to do some research on, because it's just going to take some time to get in and totally sort all this out. All right, let's go out and take a look at it in some example programs. I think that'll help make this a little bit clearer. Okay, I think looking at some code with the equals and the dot equals and the compareTo, I think it's going to make a little more sense than the slides. Hopefully you were with me on the slides, but if not, I think maybe we can clear some of this up when we're looking at these examples. So in this equals example, I have 3 string references. I have 1 which is pointing at comp sci, 2 which is pointing at the same comp sci, and then 3 is pointing at a different object that also has comp sci in it. So I've made 2 string objects, one that's just comp sci and then another one that stores comp sci. So anyway, bear with me here. This gets real sticky. It's easier if I was maybe drawing you some pictures, but I think I can get through it with the code in the same way. So let's run this through so you can see what's going on. So now here's what I've got. I've compared 1 and 2 to see if they're pointing at the same object, which they are. 1 and 2 are pointing at the exact same string because I only made 1 comp sci and I pointed them both at the same one. So if I do 1 equals 2, they're looking at the memory addresses, looking at the locations. They both store the same location, the same memory address of the same object. So that's why that one's going to print out equals. And the second check, I'm saying if 1 dot equals 2. Well, both references are pointing at the same object, so clearly they're going to have the same letters because it's the same thing. So it's going to come up true with dot equals as well. So let's change the code just a little bit. Let's change this to 1 equals 3. And then come down here and do 1 dot equals 3. So now what I'm trying to do is demonstrate the point that with the equals is looking to see if the references are pointing at the same object. In this case, 1 is pointing at comp sci, and that 3 is pointing at a distinct string that also has comp sci. But 1 and 3 are not pointing at the same objects. They're pointing at objects with the same values, but they're pointing at distinctly different objects. So 1 equals 3, if I run this again, that's going to come up false. It's going to come up not equal because they're not storing the same address. When I go down and do the 1 dot equals 3, that's coming back true because it doesn't matter if it's the same object or different objects. As long as they got the same letters, we're good to go. The only time that this comes into play with where they're pointing, it comes into play whenever you're trying to check to see if the addresses are the same. Okay, so what we had originally was we had 1 and 2. Okay, so let's back the bus up a little bit. I'm going to hit this a couple different times because I just want to make sure that it's perfectly clear as we can get it. So in this case, 1 and 2 are now pointing at the same comp sci. So when I run this through, I'm going to get true. I'm going to get equals for that first check because they're both pointing at the same object. If I do 1 equals 3, there would be 2 distinct strings with the same letters, but they would have different addresses, so the 1 equals 3 would come back false. Okay, so what I need you to do is go into the code just like I am, change up the values, mess around with it, and make sure that you understand what's going on. We're going to break this down some more as we go through the year, but this is something you're going to have to make sure that you master as we move through this. All right, with compareTo, we're looking at, with strings anyway, we're looking at the difference in ASCII value between the 2 strings. So we're going to compare the ASCII values of the first two characters that differ. In this case, 1 is pointing at the string ABC, 2 is pointing at the string DEF. I'm going to go through those strings and find the first 2 letters in the same position that differ, which would be A and D. So when I do 1 dot compareTo D, let me put my handy dandy little comment in here. I'm basically saying A minus D in terms of ASCII value. That's what I'm doing here. So that's going to come up with -3 because the ASCII value of capital A is 65 and the ASCII value of capital D is 68. So when I run this through, I'm going to get -3, and then I'm doing the same compare, well, a similar compare on the next line, except I'm doing D minus A. And so when I do D minus A, that would be 68 minus 65, which would come out with 3. So that's what you're seeing below. So if I did, say I did something like this, and I get real crazy, and I say A, B, C, and A, E, F, well, then the A and the A are the same. So now it's going to check the ASCII value of B and E. So now this would be B, this would be E, this would be E, this would be B. So now if I run it, instead of getting -3, and I still get, that's right, it still is 3. So let's change this up to say H. All right, let's do something a little different here, so we're not getting 3 every time, so that you understand that it's not always 3. Okay, let's run it. All right, now the ASCII value difference is 6 rather than being 3, but you get the idea, right? The ASCII value B minus the ASCII value of H, they're 6 apart. Because the ASCII value of H is larger than B, we get -6. And then on the other one, we take the ASCII value of H, which is 6 larger than B, so we'd get a +6. And down at the bottom, I'm comparing 1 and 2. I pointed 2 at A, B, C, the same place 1 is pointing at it. Do a compare to. They have the exact same letters in the exact same order in the exact same case, which means I get 0. So once again, the dot equals and equal equals and the compare to, you're really going to have to get into the code and mess around with it and draw some pictures on paper and move some arrows around and make sure that you totally understand how this works, because this is way more detail oriented than any of the if, else, if stuff that we were just looking at.